In this video, it's all about backups on Linux servers. And I didn't just want to create a simple rsync tutorial because I wanted to really emphasize the importance of the different backup strategies, especially if you're running a Linux server with some Docker containers, persistent volumes, or even databases that you need to back up. So in this video, I will show you a quick and easy method how to securely and automatically create a backup for your entire Linux server. And also make sure you're watching this video until the end, because then we also talk about automatic backups for databases, and there it probably gets a bit more complex, but it is really important. So don't waste time anymore, we have a lot of stuff to cover. Let's go. Hey everyone, this is Christian, and in this video let's talk about backups on Linux servers, and I want to show you how I manage my backups on my Linux servers, especially when I'm running some Docker volumes or some databases on these servers. But before we start with the actual tutorial, we also need to talk about backups in general and talk about some backup strategies. So, as IT professionals, we probably all know about the importance of backups. I hopefully don't need to explain this to you, but I still hear some misconceptions people have, especially when we're talking about redundancy versus backups and copying files away. And the first big misconception people have is that they consider a redundancy a valid backup solution. So if you don't know about this, let me explain it. So if you're running a Linux server with a redundancy option, so for example you're running a ZFS file system, or you're even running a hardware RAID where you're mirroring two hard drives, you'll always have the same data on both hard drives. And in case one hard drive is damaged or fails, you can easily replace it and you are not losing data because it's mirrored on the second hard drive. But this is not really a valid backup solution, because you're always copying all the changes. So for example, if you're accidentally deleting files, or you're doing an update and something goes wrong and you want to revert those changes, you cannot actually do this with a redundancy option. So always keep that in mind, a redundancy is not a backup. The same can also apply to simple synchronizing jobs that you do every single day to a separate location. So for example, if you just have a simple job that synchronizes your entire file system and overwrites the changes every single day, you're probably able to revert some changes that you face immediately. But if you're accidentally deleting some files, you probably won't notice it at the same day. So when you want to go back 2 weeks ago and want to restore a file that you have deleted, and you're always overriding the backups every single day, you'll not be able to restore those files. So what we need is a different solution. We need a valid, reliable backup solution that also retains the previous states of your file system. And this is why we need an incremental backup. An incremental backup always starts with a full copy of your entire file system to a separate location, but once we do the second or the third backup, we are not just copying all the files again, we are only copying the changes by still retaining the previous states of the backup. So that means we can also jump back in time and, for example, just restore a file that we have backupped 2 weeks ago and then later delete it or so. The location where we store the backup should be completely independent from our actual server. So that can be a USB stick, a second hard drive, or better, a network attached storage, or even a cloud bucket where we just store and retain those backups. Because if anything goes wrong with the hardware of the server and we need to do a disaster recovery, we need to have all the necessary files in a complete separate location that we can still access when something goes wrong with our actual server. On Linux there are many different tools existing that can create such incremental backups. So there are a lot of free and open source tools, as well as commercial products which come with some advanced features. If you want me to do a comparison video about some specific tools, then please put them in the comments. I would really like to do so. But in this video I want to show you a free and open source software that is called Duplicati, and this is a lightweight backup solution that can be easily deployed on Linux servers and even Windows servers, and I've used Portainer to deploy this in a Docker container. So by the way, if you don't know about Portainer and Docker, you definitely should check out my other videos about it, because as an IT professional nowadays you need to know this stuff. So let's first start with the deployment of Duplicati on my Portainer server, and then I will show you how you can easily use that to automatically schedule your backups. So let's go. Duplicati is a free and open source software which creates encrypted backups and can store them online. It's working on Windows, macOS and of course Linux, and you can just go to the official homepage and download it in the latest version 2.0. Consider that this is still officially tagged as a beta version, however it's pretty stable and it works very well for me. It supports many different backups, like you can create backups on local storage, network attached storage devices, or you can create a backup with a strong encryption and upload this to a proprietary cloud provider like Microsoft's OneDrive, Google Drive, Amazon S3 Bucket and many others. It's based on free and open source software, and it also comes with a nice web interface which makes it extremely easy to manage your backups. In the download section you will find an installer for Windows, common Linux distros, macOS and even a Synology image, but you will notice that it doesn't have an officially maintained Docker container image. So therefore I looked at my favorite source of cool and awesome Docker images for home servers, and this is linuxserver.io. So I've already used many of their Docker images in my previous tutorials, and they always provide many Docker images that are well supported and maintained by a large community. And they also have Docker image for Duplicati, which is basically a lightweight container image that has Duplicati automatically installed. In the official documentation you will find a Docker Compose file. You can just copy and use it for an easy deployment, but I'm going to use Portainer of course to deploy it on my cloud server. By the way, if you want to know more about Portainer, which is a nice free and open source interface to manage Docker containers and even a full Kubernetes cluster, check out my video about it. I've put your link in the description down below. So as you can see, I'm already running a lot of Docker containers on my server and I want to backup them, but of course you can also configure Duplicati to backup files of your entire server, not just the volumes. To deploy it, simply create a new container and use the image of linuxserver.io. By the way, you don't need to write down all these settings here. As always, you will find the written deployment tutorial on my blog. I always try to make it as easy as possible for you guys, so there you will find all the links, the compose templates, any scripts and commands I'm using in this tutorial. Okay, so when you deploy Duplicati on Portainer, you just need to do the settings according to the compose file, like setting the free environment variables, the TZ for time zone, which is important of course when you want to schedule your backups, and also the PUID and PGID, which configures the permissions the Docker container should have on the system. And here it gets a bit tricky, especially if you need to backup files that require root privileges to access. So for example, if you have deployed Nginx Proxy Manager that manages your SSL certs, you can usually only access them with root users for security reasons, of course. And in the Linux Server IO's compose file, it's set to the user ID 1000, which is usually the user and group ID of the first Linux user you manually create during the installation. So therefore I needed to change the PUID and the PGID to the number 0, which stands for the root user. Now we need to connect our Docker volumes, and the first volume is mounted to the /config. So this is a configuration volume for Duplicati itself, where all the config, the backup jobs, etc. are stored. Then you can create a persistent volume or path on the host system as well, where you want to store local backup. So for example, I've created the mount_backup inside the container, and I'm storing this in the var backup location on the host. Then you just need to mount all the Docker volumes you want to back up, so I recommend mounting them to a /source location, and then simply just redo this for all the volumes you need to back up files from. You can imagine this is very individual based on your setup and requirements, so this may look completely different for your server depending on the volumes and applications you want to back up. So if you need to back up the files of your host OS, you can also simply create a new volume mapping for the root directory and mount it somewhere inside the container itself. So then Duplicati also has access to the entire file system on your server. Now you could simply just expose the port 8200 like described in the compose file, but I'm using Nginx Proxy Manager, which is an awesome solution to terminate the trusted SSL cert on a secured reverse proxy and use that to encrypt and protect the web interface of Duplicati. As you can imagine, I have already created a tutorial on that, and if you want to know how to set Nginx Proxy Manager up on Portainer and you want to learn more about this, just check out my video on the channel. So in the web interface of Duplicati, we can manage our backups, and you can see I already created 2 backup jobs, but let me also walk you through step by step and let's add a new backup job. So in the first settings, you can set up a name and also set up a strong AES encryption. I would recommend using a secure passphrase, especially if you're storing these backups somewhere on a public cloud provider or on a location that could be accessed from somebody else. In the next screen, you need to select the storage type, and this can be a local folder or drive, standard protocols if you want to back up this on a network attached storage using an FTP server, SSH access or WebDAV, and you can also store the backups on proprietary cloud providers. For this example, I just want to select local folder or drive, but usually I would recommend you to store your backups somewhere else and not on the same server where you are creating the backups, despite the fact that on cloud servers the risk of losing data there is potentially lower, but in case anything goes wrong with your server, you want to have your backup somewhere else that is a completely independent location from this machine. So then you need to select your source files, and when you expand the computer tab, you see a familiar Linux file system. But be careful, this is of course not your host operating file system, it is the file system inside the Docker container, which is not persistent except for all the mount points you have mapped your volumes to. So you will find the /backup folder, which is mounted to the host operating's location on the /var/backups, if you remember. And we also have mounted our source folder, where we have access to all the Docker volumes we have mounted in this location. So let's select some of the static files inside the Nginx Proxy Manager volumes. As you can see, I'm not backing up the databases. You could technically do this, but note there's something else you need to take care of and consider, as backup databases on Linux servers is a bit more complicated. But don't worry, we will cover it in a few minutes, of course. You can also apply filters to add or exclude specific files and schedule the backup in a specific rotation. So these are all incremental backups that are compressed with data deduplication, so they are depending on each other, and you usually want to automatically schedule them and set up a backup retention job. So there are some options how long you want to store the backups on the server. I usually pick the smart backup retention, which remains one backup for each of the last 7 days, each of the last 4 weeks, and each of the 12 months, which is a pretty good plan in my opinion, and it gives you enough options to restore files from specific timestamps. So this is how a backup job looks like when it's running, and it's also pretty straightforward to restore files from a backup. So you can select a specific timestamp you want to restore files from, and then you can select if you want to restore them to the original location and overwrite the existing files or somewhere else. And you can also select every single file that should be included in the restore job and those which should not be included. Most tutorials would know just stop at this point, but we need to cover it as this is really important. So while this solution is perfect for just copying files away, if you want to back up databases with duplicity, it gets a little bit more complex here. And this is because databases work a bit different than just normal files on the file system. So when you want to do a backup of a database, you could technically just copy the database files from the file system away, but this is not really a good idea to do so. Especially with big databases where those files on the system can get really large and there are a lot of frequent updates and changes happening. This can be a really big problem, because if you start a backup and then there are some changes to the database happening while the backup hasn't already finished, you will face some inconsistencies between those database entries, and in the worst case it may even corrupt the complete database. You won't even notice it while the backup job is successfully running, but once you start recovering from this corrupted database, you will see that the backup can be completely useless in this case. So as I said, this may work for smaller databases where the backup job just takes 1 or 2 seconds and there are no changes happening within that time. You may be fine. But technically this is not really a secure and solid solution for a database backup. And there are 2 ways how you can overcome this. The easiest solution is to just stop the database container, start the backup, and once the backup job has been finished, then start the database container again. But of course this will result in a downtime, so your database or your application is unavailable during that backup period, and of course you also need to somehow automatically script that depending on the backup job. So I use another method, and that is taking an online database backup. So for example, if you're running a MySQL database, a PostgreSQL database, or even a SQLite database, there are command line tools existing that you can connect to the database server, take an online backup, and then you have a reliable backup solution for your database without shutting down the database server. And the backup tool will make sure that this backup is not corrupt and there are no changes or updates happening while this backup is running. So I've created a simple bash script that is doing an automatic backup for all my database containers that are running on my system, and then I later use Duplicati to back up those database backup files to a second location like a cloud storage or so. Let's also take a look and walk through of the script, and then you can actually use that within your own infrastructure or environment as well. You will find this backup script on my GitHub page in the scripts repository. So don't worry, I've put your link in the description below, of course. This bash script may look a bit complicated if you're not familiar with programming, but it just does the following two steps. So the first part will just set and configure the backup directory and the number of days I want to retain these database backups. And then I execute the docker ps command, which will give me a list of all Docker containers, and I'm simply filtering them based on the MySQL and MariaDB images and store them in the container variable. So this will extract all MySQL and MariaDB Docker containers that are running on my host system, and it executes the part 2 of the script for all these containers sequential. The part inside the for loop is getting the database name and the database root credentials from the environment variables of each container, which is usually stored there, and it executes the command MySQL dump, which is a CLI tool I've just mentioned that will do an online backup of these databases. The backups are stored in the backup directory, and this is defined in the static variable at the beginning. And there's also a third part inside the loop which removes all backups that are older than the defined days. So note, this only works for MySQL and MariaDB because I only use these databases. If you have other databases, for example a PostgreSQL or MongoDB or whatever, you should check out the documentation and write your own script for your database. All databases should have some CLI tools to generate a dump. In MongoDB this is MongoDump, for example. On SQLite you can do it with a backup command and so on. But you really need to find out the right CLI tools for your databases that you're using on your server. Here's also a quick example how you can use that script to back up a SQLite database, for example in a Bitwarden instance, because I'm also running Bitwarden RS on my server, and I've created a part 2 in the script that also does an automatic backup for this instance. It works the same like the instructions above, but I've just skipped the part with the credentials here because Bitwarden RS databases can be accessed without a username and password, and then I just replaced the SQL dump command with the equivalent command that works with SQLite databases. So I know that bash scripting may be new to some of you guys, but trust me, it is really important that you learn this stuff, especially if you want to manage your own servers and if you want to go down the sysadmin or DevOps path in IT, you need to know it. What I will do is I will create more tutorials on bash scripting and also Python, of course, so please let me know in the comments if you're struggling somewhere or which tutorials you want to see in the future. I also try to do more live streams on my Twitch channel where I do programming, scripting and tinkering around with this stuff, so if you want to learn it, you're not alone. Just join our Discord and jump into some of my streams and let's learn together with other IT professionals and let's just help out each other with this stuff. So once you have written your bash script and you tested it, it's creating those database dumps in your desired backup location. And you can see in this example, it's creating 3 database backups, one for my Bitwarden SQLite database and 2 MariaDB and MySQL dumps for the Nginx proxy manager and a WordPress website on my server. You could now just use this script to back up all your databases, but if you want to manage these dumps with Duplicati, let's also create a new backup job, then you can store these dump files somewhere else. And for testing purposes, I will of course just use a local folder or drive, but make sure you are creating a separate folder for each backup job where you want to store the backups. Then we can select our source files, and because we have mounted the root directory into the /source/host files location inside the Duplicati container, we can see the entire host file system under this location. So now we just want to select our 3 database dumps here that are located under the host OS homes folder, my username and backup. And you can see our 3 dump files are here. Let's select them and create a backup job for them. Of course, let's also schedule this job and set up a smart backup retention for it. And once this job is created, this backup just takes 1 second, as these databases are not really big. And it's also the same easy process if you want to restore those files like in our previous backup job. So if you need to restore a database from these dump files, you can decompress them with gzips-d and simply execute all these SQL statements that are inside these dump files. Okay, so now we have a script that can dump a database, and we can automatically run this with a cron job or create a systemd timer entry. So I may do a full tutorial on systemd jobs in the future, but here's a quick walkthrough. So first, put your scripts somewhere in a folder. Then I created 2 files that are called the .service and the .timer, and put these files in the folder etc systemd system directory. You can find these 2 templates for the systemd job also in the same GitHub repo like the database script, so just use this as a template and replace my username and the locations with yours. The first file, the db-backup.service, will define a new unit for the systemd service that executes a simple bash script. In this case, our backup script that we have stored in my home folder. It's also executed under my current user. The second file, the db-backup.timer, defines when we want to run this unit. So the onCalendar attribute can be changed to daily, hourly, weekly, whatever you need. This is just an example which executes our unit every day at midnight. Now we need to copy these 2 files inside the etc systemd system directly. Of course, you should do this with root users privileges, and you can see there are also other jobs running. To enable this, you can use the command sudo systemctl enable and then the name of the unit. You can also check if this is successfully enabled with the systemctl list timers --all. Our backup timer is listed here, but it didn't automatically run, so you can also do this by executing the systemctl enable command and add a --now. So then you can see that the next timer will be executed at midnight. And if we check our backup folder, you can see that it just created 3 new dump files. We can then later backup and encrypt with Duplicati to another cloud storage location or network storage. So I know this was a lot of information in one single video, but managing databases is not a trivial job, and you should know about how to script and backup and restore a database with CLI tools, especially if you're responsible for the database storage on your servers. Okay guys, so I hope this helped you to create a reliable backup job for your entire Linux server. If you enjoyed this video, please don't forget to hit the like button and subscribe if you want to see more tutorials for IT professionals. In some of my next videos, we will also cover backups of virtual machines or with other file systems like ZFS, snapshots and so on. But I wanted to first off create this tutorial as a starting point that can be applied on any Linux server regardless of the file system or the environment underneath, and that is also working in the Dockerized environment. And as always, if you have any questions or you're having trouble, just join our Discord community. We have a very friendly and respectful group of IT professionals there. I'm really proud of you guys, so that's really awesome. So thanks everybody for watching, enjoy the rest of your day and take care of yourself. Bye bye.